Hi everyone. We are going to be looking at our last type of function today. These are called piecewise functions. So in the last lesson we talked about step functions, and we talked about how they were line segments, or sometimes rays, but basically they were pieces of lines that took on the shape of something that looks like steps. So a piecewise function is very similar to a step function. The difference is that our pieces are not always going to be straight horizontal lines. Sometimes you're going to have a line, sometimes you're going to have a parabola. It's basically pieces of all different functions put together on a single graph. Okay, so a little bit more complicated than step functions, but again, similar. So piecewise functions are written in the same way as step functions, where you have f of x and then a big bracket and all the different functions listed there. So what this example is showing us is that part of this piecewise function is a line. That's at negative x minus 8. That's a linear function. The second part is a quadratic or a parabola, negative x squared plus 4. And then the last piece is another line. Okay, so this piecewise function is made up of a line, a parabola, and another line. So our job is to graph each of those pieces, each of those functions, over the interval that's given. Okay, so my recommendation when doing this is to use your graphing calculator. I would right now in your graphing calculator, let's look at the table for the line negative x minus 8. So if you open up a new graph and you type negative x minus 8 and you take a look, pull up the table. And what we're going to do is we're going to use our table to plot the points that are actually on the part of this graph. So if you look at the interval, it says to only graph that line from negative 9 to negative 3. So when x is between negative 9 and negative 3. So once you have your table pulled up, let's go ahead and look at where x is negative 9. And you should see that when x is negative 9, y is 1. So our first point on this piece of our piecewise function is negative 9, 1. And notice I used a closed circle because negative 9 was included in that interval. So now I have to plot points all the way until x is negative 3. So I'm just going to go right through my table. When x is negative 8, y is 0. When x is negative 1, y is negative 7. And what's kind of cool is you can see the slope of your line is negative 1, which is what it shows it was in the equation. So I can kind of follow that same pattern if I want, all the way until x is negative 3. Okay, so my line is going to connect all the way to right there. So the last point on my line here is negative 3, negative 5. And notice I'm using a closed circle because negative 3 is included in that interval. Okay, so the second piece of our piecewise function is our parabola. And so I want you guys to go and type that into your graph. You can erase the line that you have in there, or you can start a new graph page. But let's get that parabola typed in, and let's pull up the table. So negative x squared plus 4 is what we want to graph. And we're going to pull up the table. So the domain that we're graphing this over is from negative 3 to positive 3. So you're going to want to first find what is y when x is negative 3. And you should see that it's negative 5, which is interesting because it shows that negative 3 should be included. So the fact that they're the same point with the line and the parabola is good. So the next x value we want to plot is when x is negative 2, and I am seeing that y is 0. And then when x is negative 1, y is 3. When x is 0, y is 4. When x is 1, y is 3. So here's where we start to see our symmetrical shape here. When x is 2, y is 0. And remember, we're plotting all the way until x is 3. When x is 3, y is -5. And again, I'm using a closed circle because 3 is included in that interval. Okay, so let's go ahead and connect those points. Okay, so far our piecewise function has a line and a parabola. And so the last part is another line, the line y equals x. So if you want, you can type this in your calculator. It's a little bit easier to do this one by hand because if y equals x, whatever x coordinate you're plotting, y is the same. Okay, but if that's confusing to you, go ahead and type that in your calculator and pull up the table. So I need to start at x being 3. So when x is 3, y is 3. Notice, however, the interval that they gave us, 3 is not included. So I need to make sure I have an open circle on that 3. Okay, my next point would be 4, 4. When x is 4, y is 4. 5, 5. And remember, I'm going all the way until x is 7. So my line is going to end there. It's going to be a closed circle since it includes 7. And then I'm going to connect it. Okay, so there is your very first piecewise function. Very interesting. And I'm so glad they're asking for number 1, is this a function? So think about the vertical line test. If you were to draw a vertical line anywhere on this graph, would it ever pass through 2 or more points? No, right? So even where you have this open circle and this closed circle here, even if I were to draw a line there, it's okay because of that open circle. It doesn't actually count as going through that point because that point actually doesn't exist. Okay, so yes, it is. We don't have to explain. So let's go on to 2. What's the domain of this function? So the furthest left and the furthest right our function goes. Well, the furthest left it goes is -9, and it included it because it was a closed circle, so I'm using a bracket. And if I continue on, there are no gaps, so I don't have to worry about that. And the furthest to the right it goes is 7, again, including it because it has a point there. Okay, for my range, I have the lowest it goes to the highest it goes. So the lowest my graph goes is -5, including that point. And the highest it goes is 7, again, including it. Okay, X-intercept. So where does our function cross the x-axis? And it looks like we have 3 x-intercepts here. So let's list them all out. The first one I see is -8, 0. And then I see -2, 0. And the last one is +2, 0. Y-intercepts, it looks like the graph only crosses the y-axis at one place, which is 0, 4. Okay, number 6, where is the graph increasing? So remember, from left to right, if you take your finger and you follow that graph, it goes decreasing, increasing, decreasing, increasing. So we have 2 intervals where we are increasing. So remember, we go from left to right. So between what x values is the graph increasing? So starting when x is -3, all the way until x is 0, our function is increasing. So we're going to say from -3 to 0, our graph is increasing. That's our first interval. And remember, we don't use brackets because it's between those numbers. All right, so we said there was another increasing interval, so I'm going to connect that with our union symbol there. So the other interval that it's increasing is between when x is 3 and when x is 7. So 3 to 7 is the other interval where it's increasing. Okay, so for decreasing, we said that very first section there was decreasing. So between what two x values is that? That's between -9 and -3. So when x is -9 all the way until x is -3, we are decreasing. And there's a second interval that we're decreasing at, and that's when x is 0 to when x is 3. So 0 to 3. Okay. Number 8, where is y less than 0? So what does this mean? This means basically where is y negative? So looking at your graph, if I were to cover up the first two quadrants, because those two quadrants mean y is positive, I need to see the intervals below. Okay, so y begins being negative when x is -8. So from -8 to -2, all of my y values are negative. Okay, so from -8, remember this is x, when x is -8 all the way until x is -2, it's considered to be negative. Now, we don't include -8 and -2 because at those points, y is 0, and they're saying when is y less than 0. So I can't include those two numbers. Now, there's another section where y is negative, right? It's when x is 2 until x is 3. So between 2 and 3 on the x-axis, the function is also negative. So let's go back 2 to 3. Okay, just the opposite. Where is y greater than 0? So now I'm going to ignore the third and fourth quadrants, and I'm only caring about what shows up in the first and second. So the first interval that I have y being positive here is when x is between -9 and -8. Now, this is interesting. At -9, okay, so when x is -9, the y value is 1, and 1 is a positive number. So I can use a bracket when I'm saying it goes from -9 to -8, but because y is 0 when x is -8, I have to use a parenthesis on that number. Okay, so you just have to look and see what the corresponding y value is, and that will tell you if it can be a parenthesis or a bracket. All right, now there's another interval of positive y values, and that's right in the middle of our graph. So if you look where x is -2 all the way until x is +2, all of the y values there are positive. Okay, so I'm going to include from -2 to +2. Now, why am I not using any brackets there? It's because at -2, y is 0, and at +2, y is 0. So I can't include either one of those because it has to be greater than 0. Okay, and then it looks like I have one more interval here, and that is when x is 3 all the way until x is 7. So let's talk about that. When x is 3, y is actually -5, so I don't want to include 3. But when x is 7, y is +7, and since 7 is a positive number, I can include that. So my last interval is from 3 to 7 and includes that 7. Okay, I was really testing your knowledge of your interval notation. All right, number 10, where is y equal to 0? Okay, so y is equal to 0 anytime it intersects the x-axis. So we've actually already listed out our x-intercepts. So y is equal to 0 when x is -8, when x is -2, or when x is +2. So we're going to list all of those out here. When x is -8, -2, or +2. All right, number 11, find y when x equals 3. Okay, so when x equals 3, I can see there are 2 points on my graph here. Here's one of them, and here's another one. Now, the one that has an open circle actually doesn't exist. So when x is 3, y is -5. I'm only using that bottom point to answer that question because that's the one that's included. Okay, number 12, for what x values is y equal to 3? So on this graph, what points have y coordinates that are 3? And I see 2 of them. I see when x is equal to 1, y is 3, and I see when x is equal to -1, y is 3. So we can use those 2 for our answers. Okay, number 13. They're asking us here, what is the maximum value of the graph? And we have 2. We have a relative maximum and an absolute maximum. Okay, so relative maximum means look for the turning point. Okay, so if I'm looking for that turning point, I'm seeing that my relative maximum is where y is 4. So I'm kind of looking at this point right here as my relative maximum. So I'm going to say y equals 4. My absolute maximum means what is the absolute highest our graph goes. There's no arrows, so I'm going to use that point as my absolute maximum, which is 7. Okay, we need a relative minimum and an absolute minimum. Okay, so a relative minimum, again, we're kind of looking for a turning point, so it would be this point here, and that would be y is equal to -5. And an absolute minimum means what's the absolute lowest our graph goes, which is also -5. Okay. All right, so those were all the key features of piecewise functions. So now what we're going to do is we're going to go through and we're going to practice graphing these, and we'll answer some questions afterwards. Okay. So if you look, it says a piecewise function is a special type of function that consists of 2 or more pieces of different functions over various intervals. For each function below, be sure to make a table for each piece of the function over the given interval. So the reason it says that is because I really want you guys to get in the habit of just using your calculator to get these points. It just makes it so much easier when you're trying to graph these. And so I will show you exactly how I do this with tables. And so the first thing we're going to do is we're going to type in our calculator the function f of x equals x plus 5. So it's a line, the first part of our piecewise function. And once you have that typed in, I'm going to have you pull up the table for that. And what we're going to do is we are going to copy down our table from -2 down, okay, because it's saying x is less than -2. So why don't we just choose to start, let's just say -6. Okay, so can't count. -2 is the greatest value that x can be for this line. Okay, so I'm just choosing -6 as, I think, what does our graph go to? 1, 2, 3, 4, 5, 6. I could have gone to -8, but that's not really necessary. Okay, so let's copy that table down. All right, so once you have your points, we can go ahead and plot them. So when x is -6, y is -1. -5, 0, -4, 1, -3, 2. Now I'm going to be careful with this last point. -2, 3 is not included, okay, because it's x is less than -2, not less than or equal to. So I have to keep that open. Here's the rest. Now you're going to notice I'm extending my line and putting an arrow because it's less than -2, so it doesn't have an end point on that end. So that just keeps on going forever. Okay, so once you have that, let's go ahead and put in our next equation, x squared plus 2x plus 3. And this is going to be a parabola once you have it graphed. And again, we're going to pull up the table. So for the parabola, they're asking us to graph when x is greater than or equal to -2. So now -2 should be our first point, and we're going to go all the way until I'm just going to stop at 2. But again, it'll keep going. It should have an arrow on that end. Okay, so if we copy down the table, those are the values I'm getting. So what's interesting is the first point, -2, 3, is actually the same point that was on the line that we left open, but now it's included on the parabola. So I'm actually going to go back and make that now a closed circle since it's part of the parabola. And then I'm going to plot the rest of my points here. Oop, 211 is not going to fit, so I'm not going to bother with that. All right, so there is our second piece of our piecewise function. So it's a piece of a parabola. And that's it. Okay, so like I said, I think writing out the tables is a little bit easier than trying to graph these by hand or any other way. All right, let's look at example 2. So now we have two parabolas, two pieces of parabolas that we're going to be graphing here. So the first one, f of x equals x squared, we are going to graph when x is less than or equal to 0. And then our second parabola, we're going to graph when x is greater than 0. Okay, so what I would do is I would pause the video here, go ahead and put your functions in your calculator, and let's write down our table. Okay, so for the first one, since I'm looking at anything that's less than or equal to 0, 0 needs to be the biggest number on my table. So I'm just going to choose to start at -4. And then 0 is my biggest. And if I copy down that table from my calculator, those are the corresponding y values. For this one, it's saying x is greater than 0. So I am going to choose to do 0, 1, 2, 3, 4 for that. And if I copy down my table, looks like I'm getting 4, 3, 0. Okay. Okay, so when we go to graph this, let's see what we can fit here. I don't think I can even fit all of these points. I'm going to try and fit that one up here. So there's my -3, 9. There's -2, 4. -1, 1. And then 0, 0 is included because it's less than or equal to 0 on that parabola. So I'm going to connect it. So it's like half of a parabola. And don't forget your arrow, okay, because it's not stopping. It's going to keep going in that direction. Okay, now our other parabola, I'm going to plot 0, 4, but because it's greater than 0, I'm going to have that be an open circle. Okay, and then I'm going to go from there and include all of these points. Okay. And again, arrow on the end because that one keeps on going. So interesting, a half of two different parabolas, one that opens upward and one that opens downward. All right, let's look at example 3. So two lines that we're graphing here. Okay, for that first one, this might be easy enough to do without your calculator. The line y equals 5 is basically a line whose y-intercept is 5 and whose slope is 0. So we know that every point on that line will have a y-coordinate that's 5. So if I'm starting at x is -3, 1, 2, 3, I'm going to start at -3, 5. And because -3 is included, I can have a closed circle there. And so then if it's anything less than or equal to that, my line is basically just going to go on forever in this direction. Okay, so every point on that line has a y-coordinate of 5. Okay, for the second one, I will put the table for this. I think it'll make it a little easier for us. So once you have that typed in and you pull up the table, we're looking for where x is -3 and anything bigger than it. So I'm going to start at -3 and I'm just going to actually go all the way to 2. Okay, and then if we copy down our table here, so my very first point, -3, 3, should be an open circle. Okay, it's not including that point because it's just x is greater than -3. And then if we go on from there, we can include the rest. And then that is going to be a line with an arrow on the end. Okay, great. Well, you guys are hanging in there. So we're not going to make any more right now. What we're going to do is we're going to practice answering some questions. Okay, so number 4 says, which of the function definitions will produce the graph at the right? Okay, so just kind of glancing through them real quick. We can see that the very first line that we have there, kind of that first piece, has a y-intercept of 3. Okay, so I'm looking at this line here. I'm just going to draw some points in. Okay, so we can all see the y-intercept right there is at 3. And the other thing I can see is that the slope is 1. So I know the equation of that line must be y equals x plus 3. And so the reason why that's so helpful is because I can automatically eliminate choice 2 and choice 4. Because in choice 2, the y-intercept is -3. And in choice 4, the slope is -1. So that was really helpful to be able to eliminate those two choices. The next thing I would look at, since now we're looking at choices 1 versus 3, is I would look at maybe the slope of that second line, that one in the middle, and let's see what that's coming out to be. So I'm looking at this point to this point. What's the slope? So we count the rise over run, which is -6 over 1. So I know my slope of that line is -6, which is great. That eliminates choice 1 because the slope of that middle line they're saying is -3, which isn't true. Okay, so that's a great way to do process of elimination for ones like these. And you could also check, okay, are the intervals from -infinity to 1 for the first line? Yes. From 1 to 2 for the second? Yes. And then from 2 to infinity for the last? Absolutely. Does that last line segment have a positive slope like it shows in the equation? Yes. Does it look like it's going to have a negative y-intercept if I were to extend the line? Yes. So just some really good ways to check and make sure that you're on the right track. All right, number 5, regarding the graph at the right, what is the domain and what is the range? Okay, so domain, furthest left, furthest right. So the furthest left that graph goes is negative infinity. If I continue on, there are no gaps because even though there's an open circle when x is -1, there's also a closed circle there, so we're fine. And if we continue on, that graph is going to go all the way until positive infinity. Okay, the range, the lowest to the highest. So the lowest my graph goes is -3, and it's including that because there's a point there. And the highest that graph goes is infinity. Part C, which function definition will produce this graph? Okay, so another kind of process of elimination. The first thing I would look at is this piece right here. What's the equation of that line? Well, the slope is 0 and the y-intercept is 1. So that equation is y equals 1. Okay, so right away we can eliminate choice 1 because that says that the line is y equals -1, which isn't true. Now, the other thing we could do is we could figure out what is the interval that that line is covering. Okay, so the interval on that line would be from -infinity all the way to -1, and it wouldn't include the -1. So out of those 3 choices that are left, is there any that we can eliminate? Nope. Oops, I take that back. Choice 3. Choice 3 goes from -1 to infinity, so we can get rid of that one. So now we're between 2 and 4. Okay, so now we have to look at the parabola. That's going to really be the deciding factor here. So let's talk about what we know. Well, x squared, right? So they're both opening upward, but then one is a -3 and one is a +3. Well, remember, if we were to think about this in vertex form, okay, I'm just going to show you this one real quick. This, in vertex form, would look like that. And so it means that the vertex of that one is 0, -3, which is true based on the graph that we have there. So this has to be the correct one. In choice 4, the vertex of that graph would be 0, 3, +3, which is not the case. Okay? So all the things that we learn are coming back to help. Okay, number 6, regarding the graph at the right, what is the maximum value reached by this function? So the highest value that this function gets for y is 3. What is the minimum value reached by this function? So the lowest our graph goes is -3. What is the domain? So looking left to right, the furthest left our graph goes is -4. And it includes it. And there are no gaps, even though it looks like there's a gap where x is -1. There's a closed circle there, so we're okay. So this goes all the way to +4. And again, there's a point there, so we include it. What is the range of the function? So the lowest this function goes is -3, including it, because there's a point there. And if I continue to go up, the highest my function goes, there's no gaps, is +3, again including it. If this function is referred to as f of x, find f of -1. So what that means is when x is -1, what is y? So when x is -1 right here, what is y? Well, there's 2 points on our graph here that have x coordinates of -1. The problem is this one with the open circle doesn't actually exist. So we can eliminate that and say f of -1 would equal 3. Okay, last one. Write a piecewise function to represent the graph at the right. Okay, so we get to write our own piecewise function. So let's start with f of x equals big brackets. Now we're going to have 2 pieces because there's 2 lines here. So our job is to figure out the equation of that first line. Okay, so remember to write the equation of a line, you need the slope and the y-intercept. So looking at that, it looks like the y-intercept is 0. And if I put some more points on here, I can see that the slope is 1, up 1 over 1. So the equation of that line would look like 1x plus 0, which really I can just write as y equals x. Okay, so over in my piecewise function, f of x already is my y, so my equation is just x. Okay, now I have to say the interval that I graphed that equation over, or that function over. So I started that function when x was negative infinity, and I stopped when x was 0. So one way we can write that is to say we graphed this when x was less than or equal to 0. Okay, so let's do the same thing for the second line here. So this line also has a y-intercept of 0. The other thing I need is the slope. So I'm going to put some nice points here. And if I count it out, my slope is 2. So the equation of that line would be 2x plus 0, or just 2x. Okay, and the interval that that's being graphed over is when x is greater than or equal to 0. Now, here's the problem. We've already included 0 in our first line, so I cannot include it in my second line. Otherwise, technically it wouldn't be a function. Okay, so we don't know which one it really belongs to. It doesn't really matter in this case, but we're going to make sure we leave it open so that it is indeed a function. Okay, great job.